I'm Matt with MJ Harris, been here 26 years.
Hey, Corey Singley, Senior Project Manager, been with MJ Harris 11 and a half years.
We're down here at Foley, Alabama at the South Baldwin Regional Medical Center vertical expansion.
So we've got a 5-story tower addition onto an existing hospital here. 5 floors of a tower. First floor is surgery suite, lobby area, recovery areas. Second floor is a labor and delivery, women's center, postpartum rooms, C-section operating rooms. Level 3 and 4 are one wing of ICU patient rooms and another wing of med-surg patient rooms. And then the 5th floor is currently shield.
We've been out here approximately, I'd say roughly about a year, a little over a year. We started with the central energy plant relocation and some site work to free up the existing site over here so that they would have parking available for their staff, patients. So we had a step to get them some parking, turned that over, got into the CEP. We've been there for a while. We're getting equipment to get it online now, chillers, new switch gear, new generators, whole new central energy plant inside their existing with an addition.
Demo started December, January, and then got rolling with deep foundation. Over to the right, front area is a new main lobby. There's also a patient transfer that comes out this way to get patients out of the building and on their way.
These two connections right here, it's a side plate frame job, and those essentially form moment frames. And it's a proprietary system that eliminates a lot of field welding. If you had to field weld all these moment frames, we'd be out here for weeks on end, right, Curtis?
Yeah, that, or they'll take a stair tower and elevator shaft and they'll pour that out of concrete and block, and they'll use that to anchor the structure to. It eliminates all that time in that work. So.
And it gets rid of any
no
cross bracing, lateral bracing.
No cross bracing.
So it's a pretty cool system. It frees up the building for the architect a lot. It gets, we've done this on 2 or 3 jobs in California. It's the first one we've done in Alabama.
The first one doing this, it was way faster than me having to build a structural tower.
A little bit extra time in the fab shop, but saves a lot of time out here on the install.
That's probably one of the biggest side plate connections that we have on the job. But back here is all OR suite. There'll be 6 brand new state-of-the-art ORs. We're talking about going ahead and doing the additional 4 in the same time frame as we're doing the original 6. So they'll have a total of 10 operating rooms. I know there are some that are, multifunction, some that are ortho, some that are probably heart, some robotic. Yeah, so they'll have a pretty large, brand new, up-to-date, state-of-the-art surgical suite for Baldwin County, South Baldwin County.
Hi, my name's Curtis Zank. I'm a senior superintendent here on the project with MJ Harris. Been with MJ Harrison for about a year and a half now. I've been in the business now for 30 years in construction. I've built several towers for CHS and other places. I'm very excited to be down here and helping MJ Harrison and CHS again with another project. So right now we're in the process of fitting up structural steel right now on the project. We're headed into metal framing, and we're starting all our exterior studs, trying to get the building closed in, working on roofing, getting it dried in so we can really take off on the interiors on the project. All right, so out here you can see that right now we're standing on 4th floor right now, looking down onto 3rd. That's the point that we have all our splice columns on our vertical columns coming up. So they were continuous from 1 up to this height, and then we add on and go up, and that's our topping out point here on 5. So we're almost here at the end of connecting right now. Just got a few more columns to go, and then we'll interlock all the beams, and we'll be up to 5, and that'll be our roof level up there on 5. So back down here then, we're on 4, looking down on 3 again. This part is actually a roof out here. Those 2 giant tin you see down there, those are curbs for air handler. Those are just 2 of the 8 units on this project that are going to cool this building. They're in various locations on the roofs and at different elevations throughout the building. We'll get all the piping, everything will be ready for those, and then we'll fly those in as soon as they arrive on site, be able to hook them up and start cooling the building to keep it under control. So in this area right here on the deck right here, so you can see here we've already poured our concrete right here in this section. It's going to look like that with the mesh and the rebar sticking out. So all the little studs you see sticking out there, those are all welded down to the beams underneath. This is what you call a composite floor construction. So we'll add more mesh, more rebar in certain areas, and there's DBRs welded into the bent plates along the outside. All that after the concrete's on it and it cures out, creates a floor that's capable of handling the square foot of live load that we're going to be putting inside the building. But during that time when you're placing it in that wet state, a lot of these buildings are very right on the edge of being able to support all that weight during that actual initial construction phase. This is another BIM job here. So I've been building hospitals now for about the last 15 years of my 30-year career. And when we first started out back in the old days, I used to sit down with my pipe fitters and my plumbers, and we would pick the elevations that everybody's going to run through the building. We would literally establish those elevations based on beam heights, and invariably there would be some spot where we missed a beam that was thicker or heavier. We'd all be standing there staring up trying to figure out how we're going to get around all that and stay above the ceiling. Now we have BIM available to us where there's a whole set of people that draw all the mechanical, like you see all this heavy conduit, these racks and all these hangers getting ready for this piping to come down. They draw it all in, so when we're out here on the job, we don't lose days and weeks trying to figure out how to get by each other and under each other. It's already completely designed out. A lot of it comes in prefab from factories now, so you need less manpower on the job site, and it goes up into place. So that whole BIM process, I'm gonna tell you, we probably got about 8 months probably in that process right now, I think, Matt. And they're close right now. They got a little bit of things they're fine tuning on the upper floors. For the most part, we can follow that pretty accurately. They're not perfect either, and we can come down through here. So when we start stacking things in a hallway like this, even though I got a 20-foot ceiling in here, by the time I'm done, I'm fighting to keep things 4 inches above the lights and above the grid so we can get the stuff in. So there are even a couple places where we requested to lower the grid inside the hospital on this floor in order to get everything in here. When you look in here and it looks like there's that much space, that space disappears very rapidly because of all the mechanical requirements in a hospital.
In addition to the BIM work that's being done, looking up, it's level 2 above us, composite slab above us, so pre-pour, they set all the bangers in prior to the pour and project down, so when it's time to get to hanging overhead rough ends, those hangers are already there, make quick work. We don't have to go through drilling and adding hangers after the pour.
Yeah, so if you can imagine a guy in a scissors lift going up and down 20 feet up in the air, clamping things onto beams and trying to put hangers in and then material in place. You can walk across the deck, drop all those in 3 days. They drop all those hangers in and they're done. They're just gonna grab those things, throw all thread in them, grab those straps and put their duct to them and rock right through here.
Pretty much a one-man operation with the technology we have today. They use a robotic total station, guys out in front of them, laying it out, crews coming behind. There's no pulling tapes, that downtime of measuring off this or that. The guys put the mark, slap it in, and they roll the next spot.